Nothing lasts, not even atoms. The atoms in your left hand were forged in a star that died 5 billion years ago. The atoms in your right hand came from a different star. They found each other here briefly to become your hands. They won't stay. Within a year, 98% of the atoms in your body will be gone, replaced, scattered, repurposed into soil, air, other living things. You are not a thing. You are a pattern passing through matter. 25 centuries ago, a man sitting under a tree in northern India observed this about his own experience, not with a microscope, not with mathematics, but with sustained, unflinching attention. He called what he saw a nikka, inconstancy. Everything fabricated is inconstant. Everything built falls apart. Everything gathered scatters. 23 centuries later, a physicist in Germany arrived at the same conclusion from the opposite direction. He called it the Second Law of Thermodynamics. The entropy of the universe tends toward a maximum. Order decays, stars die, atoms scatter. Tonight, what happens when these two ways of seeing impermanence meet? One looked outward, at matter. The other looked inward, at mind. They never heard of each other, and they described the same thing. Chapter 1. The Law. There is a law in physics unlike any other. Most laws of physics are symmetrical. Newton's equations work the same forward and backward in time. Maxwell's equations for light do not care which direction the clock runs. Quantum mechanics, at its deepest level, cannot tell the difference between past and future, but there is one law, exactly one, that breaks this symmetry. One law that gives time a direction. One law that says this way, not that way. Forward, not backward. It is the second law of thermodynamics, and it may be the most universal statement science has ever made about the nature of reality. The story begins in 1865 with a German physicist named Rudolf Clausius. He was studying something practical: steam engines, heat, the movement of energy from one place to another, and he noticed a pattern so consistent that he gave it a name. He called it entropy, and he wrote a sentence that would reshape how we understand the universe. The entropy of the universe tends toward a maximum. What does that mean? The first law of thermodynamics says energy is conserved, it never disappears. The total amount of energy in the universe today is exactly what it was at the moment of the Big Bang. Nothing is lost. The second law says something more unsettling. Energy is conserved, but it disperses, it spreads out, it moves from concentrated, useful forms into diffused, unusable forms. A hot cup of coffee in a cold room will always cool down. The heat does not vanish. It spreads into the air, the table, the walls, until everything is the same lukewarm temperature. And then nothing more can happen. The energy is still there, but it can no longer do anything. That cooling cup of coffee is the universe in miniature. 12 years after Clausius, an Austrian physicist named Ludwig Boltzmann saw something deeper. He realized that entropy is not a force. Nothing pushes the universe toward disorder. Entropy increases for a reason far more fundamental than any force. It increases because of mathematics, because of probability. Consider a deck of 52 cards. There is exactly one arrangement in which the cards are perfectly sorted, ace through king, suit by suit. One arrangement, but the total number of possible arrangements of those 52 cards is approximately 8 followed by 67 zeros, a number so large it has no intuitive meaning. Every single one of those arrangements is equally likely, but only one of them is ordered. Shuffle the deck once, and what happens? You almost certainly move away from order, not because something forced you to, but because there are incomprehensibly more disordered states than ordered ones. Shuffle again, and you move further. The odds of returning to perfect order by chance are so small that if every person on Earth shuffled a deck once per second from the beginning of the universe until now, it would almost certainly never happen. Not once. You see this every day without naming it. You have never seen a cold cup of coffee spontaneously grow hot by drawing heat from the air around it. You have never seen a shattered glass leap from the floor and reassemble on the counter. You have never seen the grey streaks in your hair darken back to the colour they were at 20. Not because these things violate any conservation law. The energy is all still there, the molecules are all still present. The pigment chemistry is unchanged. They do not happen because they would require an astronomically unlikely decrease in entropy. They would require the universe to shuffle the deck and land by chance on the one ordered arrangement out of incomprehensible trillions of disordered ones. It is not impossible. That is the strange precision of the second law. It does not say never. It says so overwhelmingly unlikely that the difference between improbable and impossible vanishes for any practical purpose. The cold coffee could, in principle, grow hot. The glass could reassemble. Your hair could reverse its graying, and you could shuffle a deck of cards once and find them perfectly sorted. The probability is not zero. It is merely so close to zero that the universe does not have enough time left to make it likely. This is entropy, not a force. A probability so overwhelming it functions as a certainty. And this is what makes the second law different from every other law in physics. It is the only one that distinguishes past from future. Run a film of a cup shattering on a kitchen floor. Every viewer knows instantly that film is running forward. Now reverse it. Shards leap from the floor, reassemble into a perfect cup, and the cup floats upward onto the counter. Every viewer knows that is absurd. That absurdity is entropy. The physicist Carlo Rovelli, in his widely read book The Order of Time, put it starkly. He argued that the entire difference between past and future may be attributed solely to the fact that the entropy of the world was low in the past. That is all. That single fact, that the universe began in an extraordinarily low entropy state, is the reason time has a direction. The reason we remember yesterday, but not tomorrow. The reason causes come before effects. The reason anything happens at all. Rovelli went further. He argued that the world is not a collection of things. It is a collection of events. Things persist. Events occur and pass. And if the world is made of events rather than things, then impermanence is not something that happens to reality. Impermanence is what reality is. He wrote that we are stories contained within the 20 complicated centimeters behind our eyes, oriented toward the direction of increasing entropy, not permanent structures moving through time. Stories with a beginning, a middle, and an ending that the laws of physics guarantee. The fact that the story ends does not make it meaningless, but it does mean that anyone who mistakes the story for something permanent, something that will simply continue indefinitely without dissolution, has misunderstood the most basic fact about the medium in which the story is being told. On the other side of the ancient world, from both Clausius and Rovelli, and 23 centuries before either of them, Heraclitus, a Greek philosopher writing around 500 BCE, noticed something similar. His actual words, preserved as fragment B12, are subtler than the popular version most people know. He did not say, "You cannot step into the same river twice." That is Plato's later paraphrase. What Heraclitus actually wrote was this: "Upon those who step into the same rivers, different and different waters flow. The rivers stay the same. The waters change. Identity persists while substance flows through. Now extend what Clausius saw in steam engines to the scale of the cosmos. A star is a temporary pocket of order. Hydrogen atoms fusing under gravity, releasing energy, holding a shape for billions of years. But the second law is patient. Every star that has ever existed is either still burning through its fuel or has already exhausted it. Our sun has roughly 5 billion years left. After that, collapse, expansion, dispersal. The atoms that make up the sun will scatter into interstellar space, where some of them may find their way into new stars, new planets, new configurations of matter, temporary configurations, and at the farthest edge of what physics can project, timescales so vast they make the age of the universe seem like a camera flash, there is a prediction. After the last stars burn out, after the last black holes evaporate through a process called Hawking radiation, after all structure in the universe has dissolved, the universe reaches maximum entropy, a uniform, low-energy sea of photons near absolute zero, with no gradients, no structures, no processes. Nothing left to happen. This is what physicists call the heat death of the universe. We will return to this, because where physics ends its description, Buddhism has something precise to say. But for now, this is the law, the most universal law in physics. It has no known exceptions. Every structure, every configuration, every moment of order in the universe is temporary. Every pattern, from a snowflake to a galaxy to a civilization, is borrowed time made visible. And the law does not only apply to stars. Chapter 2. Not even atoms. We are made of star stuff. That line belongs to the astronomer Carl Sagan from his 1973 book, The Cosmic Connection. 7 years later, in the opening episode of his television series Cosmos, he gave it its full weight. The nitrogen in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff, not metaphor, not poetry dressed as science. Literal fact. The iron atom circulating in your blood right now was forged in the core of a massive star that lived and died billions of years before the Earth existed. That star burned through its hydrogen, fused helium, then carbon, then oxygen, then silicon. Each stage hotter, each stage shorter, until it reached iron. Iron is where fusion stops. Iron is the element that cannot give back more energy than it cost to make, so the star collapsed under its own gravity, and in the catastrophic explosion that followed, a supernova, it scattered its elements across space. Those elements drifted for millions of years through interstellar clouds until gravity gathered them again into a new solar system. Our solar system, your body. You are not merely standing on a planet that orbits a star. You are made of dead stars, multiple dead stars. The calcium in your right hand may have come from a different supernova than the iron in your left. You are a collaboration of stellar debris, temporarily assembled into a shape that can wonder about its own origins. And that shape is not as stable as it feels. Research conducted at Oak Ridge National Laboratory established that approximately 98% of all the atoms in the human body are replaced within a single year. The lining of your stomach replaces itself every few days. Your skin turns over in 2 to 3 weeks. Red blood cells last about 4 months. The skeleton, the part of you that feels most solid, most permanent, replaces itself roughly every 10 years. You are not a thing. You are a river, not metaphorically, structurally. A river maintains its shape, its name, its identity on a map, while the water that constitutes it at any given moment is entirely different from the water that constituted it an hour ago. Your body does the same. The pattern persists. The matter flows through. What you call my body is a shape that matter passes through on its way somewhere else. Heraclitus saw the river. Sagan saw the stars. The second law sees the principle underneath both. Every arrangement of matter is temporary, because entropy ensures that order disperses. But the impermanence goes deeper than atoms moving through your body. Go smaller. Look at what an atom actually is. An atom is not a tiny solid ball. That image, hard little spheres, neatly stacked, belongs to 19th century physics. What 20th century physics discovered is stranger. An electron is not a particle orbiting a nucleus the way a planet orbits a star. An electron is a probability cloud, a smeared out mathematical function describing where the electron is likely to be found, but never pinning it down completely. The nucleus itself is a seething knot of quarks held together by gluons, force-carrying particles that are constantly being exchanged, created, and annihilated. The empty space inside an atom is not empty. It churns with virtual particles, matter and antimatter pairs that pop into existence and vanish again on timescales of 10 to the negative 21 seconds, a billionth of a trillionth of a second. A stable atom is not still. It is a dynamic process that merely appears stable because it sustains its pattern over timescales much longer than a human life. But even that apparent stability has limits. Radioactive atoms transform on their own. No outside force needed. And even the most enduring structures in the universe, the protons inside every atom, may not last forever. Theoretical physics predicts that protons themselves may decay on timescales of 10 to the 34th years or longer. That prediction remains unproven. No one has observed a proton decay, but physics so far has found no structure that is exempt from impermanence. The timescale may be unimaginably long, but the direction is always the same. Nothing lasts, not even atoms. In 1944, the physicist Erwin Schrödinger published a small book called What is Life? In it, he asked a question that biology had not yet answered. What makes a living organism different from dead matter? His answer was precise and unsettling. What an organism feeds upon, he argued, is negative entropy, order, structure, low entropy energy. A living body is a temporary pocket of order maintained by constantly consuming order from its environment. You eat food, highly structured molecules, low entropy arrangements of atoms, and you break those molecules apart, extracting their order to maintain your own, and you export the disorder as heat, as waste, as exhaled carbon dioxide. You are not violating the second law. You are exploiting it. You are riding a gradient. The gradient between the low entropy energy of sunlight captured by plants and the high entropy waste heat radiated into space. Life exists in that gradient. Life is what happens when matter finds a way to increase the entropy of the universe more efficiently by organizing itself temporarily into complex structures. You are the universe's way of falling apart faster. And even this extraordinary, improbable, temporary arrangement is what the second law guarantees will not last. The gradient that sustains you will flatten. The order you borrow will be returned. The pattern that is you will dissolve back into the matter that briefly held it. This is where a physicist might stop. The observation is complete. The mechanism is described. The law is clear. But 25 centuries before Schrödinger, someone made the same observation and kept going. He did not stop at description. He asked, if this is true, if everything fabricated is inconstant, if every pattern is temporary, if nothing conditioned can be held, then what do you do? How do you live inside a reality where nothing you love, nothing you build, nothing you are will remain? Science describes the mechanism. Buddhism describes what to do with the mechanism. Chapter 3. The same observation, different instruments. The Buddha did not have a thermometer. He did not have mathematics. He did not have a particle accelerator or a telescope or a spectrometer. He had a different instrument, his own mind, trained to observe his own experience with a precision that most people never attempt. And what he found, looking inward, is structurally identical to what physics found looking outward. In the Girimananda Sutta, N 10.60, the Buddha describes the first of 10 perceptions that lead to liberation, the perception of inconstancy. The instruction is direct. There is the case where a monk, having gone to the wilderness, to the shade of a tree, or to an empty building, reflects thus: form is inconstant, feeling is inconstant, perception is inconstant, fabrications are inconstant, consciousness is inconstant. Thus he remains focused on inconstancy with regard to the 5 aggregates. Notice the scope, not just the body, not just matter. The Buddha instructs the practitioner to observe inconstancy across all 5 aggregates of experience: form, feeling tone, perception, mental fabrications, and consciousness itself. Physics observes impermanence at the level of matter and energy. The Buddhist instrument observes impermanence at every level of experience that a human being can access. The body changes. Yes, the physicist knows this. But feelings change. Perceptions change. The mental constructions you use to make sense of the world, they change. And consciousness itself, the awareness that seems to be the one constant, the observer behind the observed, even that, the Buddha says, is inconstant. 2 instruments, same territory, but the Buddhist instrument covers a wider range. Consider what this means in practice. The physicist can measure the half-life of a radioactive atom. The physicist can calculate the rate at which your body replaces its cells. The physicist can track the dispersal of heat from a cooling star. All of this is impermanence observed from the outside, third person, measured, precise. But the physicist's instrument cannot measure the moment when a feeling of contentment shifts into restlessness. It cannot track the exact point at which your confidence in a decision begins to erode. It cannot register the instant when the perception of a friend's face, a perception you thought was stable, fixed, permanent, quietly rearranges itself after a single conversation that changes what you see when you look at them. The Buddhist practitioner can, not with a spectrometer, with attention, sustained, trained, deliberately focused attention to the arising and passing away of experience in real time. This is what the Buddha means when he says he remains focused on inconstancy with regard to the 5 aggregates. He is not asking the practitioner to think about impermanence as a concept. He is asking the practitioner to watch it happen, in the body, in feeling tone, in perception, in mental construction, in consciousness itself. The way a physicist watches entropy happen in a closed system. Same rigor, different instrument, different scale, and there is a subtlety in the Buddha's language that physics does not capture. The translator Thanissaro Bhikkhu consistently renders anicca not as impermanence, but as inconstancy. The distinction matters. Impermanence means things end. Inconstancy means something more. Things are unreliable. They cannot be made into a permanent refuge. A thing that is merely impermanent might still be worth clinging to while it lasts. A thing that is inconstant, that shifts, fluctuates, and cannot be depended upon even while it exists. That calls for a fundamentally different relationship. The physicist says, this will end. The Buddha says, this cannot be relied upon. And that unreliability is not a tragedy. It is a doorway. The Buddha also knew that description alone is not enough. People do not change because they are told that things are impermanent. They change because they see it, feel it, in their own experience, with a vividness that bypasses the intellect and reaches something deeper. And so the Buddhist tradition is rich with images designed not to explain impermanence, but to make you experience it. In the Araka Sutta, in 7.74, the Buddha offers a sequence of similes for the brevity of human life, each one more vivid than the last. A mountain river. A river flowing down from the mountains, going far, its current swift, carrying everything with it, so that there is not a moment, an instant, a second where it stands still, but instead it goes and rushes and flows. This is the closest the ancient texts come to the physicist's arrow of time, a process with a direction, carrying everything in its current, never pausing, never reversing. The river does not negotiate. It does not slow down for what you love. It goes and rushes and flows. Notice what the Buddha does not say. He does not say the river carries some things and spares others. He does not say the current is swift for the unlucky and gentle for the deserving. He says it carries everything, with every living being in its current, the young, the old, the wise, the foolish, the person who has planned carefully, and the person who has not planned at all. The river does not sort. It does not judge. It does not make exceptions for those who have not yet finished what they started, who have not yet said what they needed to say, who are not yet ready. It goes and rushes and flows, and there is something the simile implies that is easy to miss. You are not standing on the bank watching the river. You are in it. You have always been in it. There is no vantage point outside the current from which to observe impermanence at a safe distance. The physicist can stand outside a closed system and watch entropy increase. The meditator cannot stand outside experience and watch it change. The meditator is the experience that is changing. This is what makes the Buddhist observation more intimate, more unsettling, and ultimately more transformative than the physicist's. The physicist describes a universe that is falling apart. The Buddhist practitioner discovers that the observer is falling apart too, a dewdrop on the tip of a blade of grass. When the sun rises, it vanishes. It was there. It caught the light. For a moment, it was beautiful, and then it was not there. This is impermanence at the scale of fragile, brief order. A temporary configuration so delicate that the slightest change in conditions dissolves it. Schrödinger's living organism, translated into an image a child could understand. A bubble on the surface of water when rain falls on a puddle. It forms. For a fraction of a second, it holds a perfect sphere. Surface tension against the air, a tiny dome of order. And then it is gone. Not slowly, not gradually. Gone. The bubble does not decay. It simply ceases. One moment it exists. The next it does not. You know these images, not from scripture, from your own life. You have watched a morning's confidence dissolve into an afternoon's doubt, and you could not say exactly when it changed. You have felt a relationship that seemed permanent reveal itself over the course of a single week, as something that had been shifting for years without your noticing. You have looked in a mirror and seen, for the first time, a face that is no longer the face you carry in your mind, and realized that the change did not happen today. It happened gradually, imperceptibly, the way a river changes the shape of its banks, not in a single dramatic collapse, in a continuous, quiet rearrangement that you only notice when the distance between what was and what is becomes too large to ignore. The Buddha is not describing something exotic. He is describing what is already happening to you, what has always been happening to you, with a clarity that most people spend their entire lives avoiding. Each simile is a different instrument reading the same data. The river reads the direction, entropy's arrow times one-way current. The dewdrop reads the fragility, how little it takes to undo what briefly held together. The bubble reads the speed, how quickly a pattern can vanish, how thin the membrane is between existing and not existing. And the Buddha was not offering these images as philosophy. He was offering them as medicine. Because the next step, the step physics does not take, is what makes the Buddhist observation different from every other tradition that has noticed impermanence. In the Dhammapada, verse 277, DHP 277, the sequence is laid out with a precision that reads almost like a formula. When you see with discernment, all fabrications are inconstant, you grow disenchanted with stress. This is the path to purity. 4 words at the end, the path to purity. These 4 words are the entire distance between the physicist's conclusion and the monk's. The physicist observes that entropy increases. The observation is correct. The physicist may feel melancholy about it, or wonder about it, or write beautifully about the fragility of things. But the physicist's job ends at description. The map is drawn. The territory is charted. Here is what is happening. Here is the law. The Buddha draws the same map and then keeps walking. Observation leads to disenchantment, not depression, not nihilism. Disenchantment, the falling away of the enchantment, the spell, the deeply held belief that something conditioned can be made into a permanent refuge. And disenchantment leads to dispassion, and dispassion leads to freedom. This is the path to purity. Not a theory about purity, a path to it. Physics ends at entropy increases. Buddhism continues with, and this is what to do about it. You have seen this sequence before. In the Anattalakkhana Sutta, SN 22.59, the Buddha taught his first 5 disciples the chain that links the 3 characteristics. What is inconstant is stressful. What is stressful is not fit to be regarded as self. Inconstancy leads to the recognition of suffering. Suffering leads to the release of identification. Tonight, physics shows us why the first link in that chain, inconstancy, runs as deep as anything science has ever measured, and the practice is not abstract. In the Anapanasati Sutta, MN 118, the Buddha gives a direct instruction for bringing the perception of inconstancy into the body's most immediate, most intimate rhythm. He trains himself. I will breathe in focused on inconstancy. I will breathe out focused on inconstancy. The breath itself is impermanent. Each inhalation is different from the last. Each exhalation will never be repeated. This is the Buddhist equivalent of the physicist observing entropy at the smallest accessible scale. Not stars, not atoms, but the breath moving through your body right now. The instrument is always available. The observation never ends. Science describes the mechanism. Buddhism describes what to do with the mechanism. Chapter 4, Where they meet and where they part. 2 traditions, 2 instruments, 2 ways of looking at the same reality, one from the outside, one from the inside. They were separated by 23 centuries, by thousands of miles, by entirely different methods and entirely different goals. And yet, when you place their observations side by side, the convergence is striking, not because one confirms the other. Neither tradition needs the other's permission. The second law of thermodynamics was true before the Buddha was born. The perception of anicca was precise before Clausius named entropy. What is striking is not confirmation. It is the fact that two completely independent investigations of the nature of reality, using completely different instruments, arrived at structurally similar descriptions, and where they diverge is as illuminating as where they agree. They converge in three places. They part in two. The first convergence is directional. The second law gives time an arrow. Entropy increases. The past had more order than the present. The present has more order than the future. This is not a tendency. It is not a suggestion. It is the only law in physics that points, that says, this way forward toward dissolution and never back. The Buddha also observed a direction, but he did not stop at describing it. He followed it. In the Dhammapada, DHP 277, the direction becomes a path, a sequence with a destination. See inconstancy. Grow disenchanted with what cannot satisfy. Arrive at purity. The physicist found a direction. The monk found a path. Both point the same way. Both say, everything conditioned moves toward dissolution. But only one continues past the observation. Only one says, and here is where that recognition leads, if you follow it all the way through, the arrow of time and the path to purity. Same direction, different destinations. The arrow ends in description, the path ends in freedom. The second convergence is the refusal to despair. This is important because impermanence, seen from a distance, looks like a counsel of hopelessness. Everything falls apart. Everything you build will be undone. Everything you love will be lost. If that is the final word, then the only honest response is grief. But neither tradition makes that its final word. Schrödinger saw that life itself is the universe's temporary exception, a pocket of order sustained by consuming order from elsewhere. And that exception is not meaningless. It is extraordinary. Out of all the possible arrangements of matter in the universe, the overwhelming, incomprehensible majority of which are disordered, here, briefly, atoms have organized themselves into a structure that can observe itself, that can ask questions, that can love and grieve and wonder. That is not nothing. That is the most improbable thing in the known universe. The Buddha saw the same thing and reached the same refusal. Anicca is not a reason to give up. It is the beginning of waking up. This is the path to purity, not this is the path to despair. The recognition that nothing conditioned can be held is not the end of meaning. It is the end of the wrong kind of meaning, the kind built on the assumption that something conditioned can serve as a permanent refuge. When that assumption falls away, what remains is not emptiness. What remains is clarity. Two traditions, same observation, same refusal to collapse into nihilism. The physicist says, the exception is extraordinary. The monk says, the recognition is liberating. Neither says, give up. The third convergence is complementarity. Physics looks outward. Impermanence at the scale of atoms, stars, galaxies, the universe. The second law describes what happens to matter and energy across all scales of space and time. It is powerful precisely because it is universal. There is no known structure in the physical universe exempt from entropy. Buddhism looks inward. Impermanence at the scale of sensations, feelings, perceptions, thoughts, states of mind. The five aggregates are the Buddhist map of experience, and anicca applies to every region of that map, not just the material one. The body changes, yes, but the feeling of contentment that arose 5 minutes ago has already shifted. The perception of who you are is not the same perception you had at 20. The mental constructions you use to understand the world are rebuilt constantly without your noticing. Neither instrument alone gives you the complete picture. Physics can explain why the atoms in your body scatter. Only the Buddhist analysis can explain why the mind suffers from the scattering. Physics describes impermanence at the scale of the cosmos. Buddhism describes it at the scale of a single breath. You need both instruments, one pointed outward, one pointed inward, to see the full territory. Those are the three convergences: direction, resilience, complementarity. Two careful observers of the same reality, using different instruments, arriving at descriptions that illuminate each other without collapsing into each other. But they do part, and the places where they part are as important as the places where they meet. The first disagreement is about how impermanence feels. Physics, when it contemplates entropy, tends toward elegy. Rovelli writes with beauty and melancholy about the fragility of existence, about how we are brief stories contained within 20 complicated centimeters behind our eyes, oriented toward increasing entropy. There is a sorrow in the physicist's voice, a tenderness toward what is passing. Science offers a description of breathtaking precision and no prescription. Here is what is happening. Here is the law. I am sorry, there is nothing to be done. Buddhism says something radically different. When impermanence is seen clearly, not as an idea, but as a direct perception, sustained and unflinching, the response is not sorrow, it is release. The Dhammapada does not say, when you see that all fabrications are inconstant, you will grieve. It says you grow disenchanted. The enchantment breaks, and what follows the breaking of the enchantment is not loss. It is freedom from a misunderstanding that was causing suffering all along. The physicist says, things fall apart, and that is sad. The Buddha says, things fall apart, and seeing that clearly is the beginning of the end of suffering. Same observation, opposite emotional conclusions. The difference is not in what they see. The difference is in what they do with what they see. The second disagreement is about where impermanence ends, if it ends at all. Here we return to the heat death of the universe. The second law's final conclusion about conditioned physical reality. After the last stars burn out, and they will, every one of them, over timescales of trillions of years, after the last black holes evaporate through Hawking radiation, a process that takes roughly 10 to the 100th power years, after every atom has either decayed or been scattered into the expanding void, the universe reaches maximum entropy, a featureless sea of low-energy photons, uniform in temperature near absolute zero. No gradients, no structures, no processes, no events, nothing left to happen. The second law, fully realized, leaves nothing. This is the fate of everything conditioned. Everything that arose from conditions, every star, every planet, every molecule, every living being, every thought, every civilization, returns to disorder. The law has no exceptions. And here is where Buddhism says something that physics cannot address. In the Nibbana Sutta, UD 8.1, the Buddha states, there is, monks, an unborn, unbecome, unmade, unconditioned. If there were not that unborn, unbecome, unmade, unconditioned, there would be no escape discerned from what is born, become, made, conditioned. The unconditioned. Asankata, Nibbana. Physics describes the fate of everything conditioned, and entropy governs all of it without exception. But the Buddhist unconditioned, by definition, lies outside the domain that entropy addresses. It is not a place that matter goes when it runs out of order. It is not a state that the universe reaches after sufficient time has passed. It is not the heat death under a different name. Heat death is the final condition of conditioned reality. Maximum entropy, maximum disorder, the end of all structure. The unconditioned is something else entirely, defined precisely by the fact that it is not born, not become, not made, not conditioned. Physics has nothing to say about Nibbana. Not because physics disproves it, not because physics finds it unlikely, but because Nibbana, if it exists, lies outside the domain that thermodynamics addresses. The second law governs the conditioned universe. Every particle, every field, every configuration of energy. What lies beyond the conditioned is, by the rules of the physicist's own method, outside the physicist's jurisdiction. This is not a weakness of physics. It is an honest boundary. Physics describes what it can measure with extraordinary precision. Buddhism points toward what measurement cannot reach. Neither is wrong. They are looking through different instruments at different, though overlapping, domains of reality. The law and the path, the mechanism and the response, the conditioned and the unconditioned. Between them, everything that matters about being human. Close the atoms in your hands. You have been holding them throughout this conversation. Or rather, they have been holding you. The ones in your left hand, forged in a star that collapsed before the earth existed. The ones in your right hand, from a different star, a different explosion, a different corner of the galaxy. They drifted for millions of years through interstellar space, found their way into a planet, into soil, into food, into you. They are here now. They will not stay. Within a year, most of them will be gone. Exhaled, shed, excreted, replaced by other atoms from other sources, continuing their long transit through forms that briefly hold them and then release them. The pattern that holds them together, the pattern that is you, is Schrödinger's temporary exception, a pocket of order in a universe trending toward disorder, an arrangement so improbable, so brief on the cosmic timescale, so dependent on a continuous flow of low entropy energy from a middle-aged star 93 million miles away, that its existence is not ordinary, it is extraordinary. And it is extraordinary precisely because it will not last. If it lasted forever, it would not be extraordinary. It would just be furniture. The universe's brief exception is precious because it is temporary. Clinging to it as permanent, insisting that this body, this mind, this configuration of matter and consciousness will hold, is the source of suffering. Seeing it clearly as temporary, seeing it the way the physicist sees entropy and the way the Buddha sees anicca, is the beginning of freedom, not freedom from life, freedom within it, freedom from the enchantment that says, this will stay, this must stay, I cannot bear it if this does not stay. The Buddha knew what the refusal to see impermanence costs. In the Araka Sutta, A, N7.74, after the river, after the dewdrop, after the bubble, he offered one final image, the most unflinching one. He saved it for last, and so have we. A cow being led to the slaughterhouse, with every step of its foot closer to its slaughtering, closer to death. That is you. That is every living being. Every step you take, every breath, every heartbeat, every moment of consciousness is a step closer, not metaphorically, literally. The second law ensures it. Entropy does not pause. The river does not stand still for a moment, an instant, a second. And the Buddha's response to this, the response that separates Buddhism from every other tradition that has stared into impermanence, is not grief. It is not denial. It is not bargaining for more time. It is 4 words. This is the path to purity. DHP 277. The cow walks toward the slaughterhouse. The physicist describes the walk with precision, the mechanics of each step, the thermodynamics of the body, the entropy increasing with every metabolic process that keeps the legs moving. The description is correct. The description is complete. The description changes nothing. The Buddha describes the same walk and says, "When you see this clearly, you are free. Not free from the walk, free from the belief that the walk could have gone somewhere else, free from the exhausting, futile effort to make the impermanent permanent, free to walk each step fully, without the suffering that comes from demanding that the steps never end." Science describes the mechanism. Buddhism describes what to do with the mechanism. Science looked outward and found a law, the second law of thermodynamics, the most universal statement physics has ever made, the only law that gives time a direction. Everything conditioned falls apart. Order disperses. Stars die. Atoms scatter. The arrow points one way, and it does not turn back. Buddhism looked inward and found a path. The perception of inconstancy, sustained across every aggregate of experience, leading to disenchantment, to dispassion, to freedom. Everything fabricated is inconstant. Everything clung to as permanent becomes a source of suffering. The path points one way, and it does not turn back. The second law tells you what is happening. The three perceptions tell you how to respond. Between the law and the path, between entropy and anicca, is everything that matters about being alive.